In this video, I am going to look at annuities with regular withdrawals. So this is very similar to what we're used to with annuities, where a regular amount of money goes into an investment account, but it's the reverse. So we're starting with a lump sum, and a certain amount of money is being withdrawn on regular time intervals. So essentially, in this example, we've got a superannuation payout of 250,000, and the person is living off this superannuation. So every month they're withdrawing $3,000. The question's asking us to find the value of the annuity or the lump sum, the superannuation, after 2 months of spending or withdrawals, and then after 5 years. So as usual with this type of question, we start with a summary. So my initial amount, my present value is 250,000. My rate is 12% per annum, but it is calculated monthly. So I need to convert things to months. So that would be 1% per month or 0.01 as a decimal. For part A, my N is 2 months. And for part B, we've got 5 years, 5 times 12, that would make it 60 months. Okay, I am going to again start with the number line because it helps me identify what's going on. It's a nice visual aid to make sure I don't make mistakes. So we're starting with 250,000. That's at the beginning, on the first day. And then at the end of the first month, I am withdrawing $3,000. So that's first month. And then at the end of the second month, I am withdrawing another 30,000. 3,000. Now, again, with these types of questions, we assume any changes happens at the end of the month unless, or end of the time period, unless the question says otherwise. So I might just put the third, and then we are going to go all the way to 60 because that's all my questions interested in. For all of these questions, again, we have to establish a pattern, and part A is there to help us establish a pattern. Now, I'm going to treat this more like a home loan repayment, even though it's an annuity. So my amount at the end of month 1 is going to be, well, I've got my principal that's going to be sitting there for 1 month and accumulating interest, so 250,000. 1 plus R, that's 1, might just do that, 1.01, and that sits in the account for 1 month. After that, I'm withdrawing $3,000. Now, I could go and calculate this, but I also want to establish a pattern for my part B. So I'm not actually going to make any calculations at this stage. I am going to just leave my answer as that for A1. I'm now going to work out A2. So when I get to the end of the first month, in my account, there is no longer $250,000. In my account, there is A1. And that A1 is now going to accumulate interest. So just like home loan repayments, I have A1 being multiplied by 1.01 for 1 month, and I'm going to then withdraw $3,000. And just like with home loan repayments, I am now going to substitute all of this for A1. So when I do that substitution, I get 250,000, 1.01 minus 3,000, that's my A1. That is being multiplied by 1.01 minus 3,000. And just like with home loan repayments, I'm now going to expand this bracket by multiplying the term outside with everything inside. So that gives me 250,000, 1.01 squared minus 3,000. Take the 3,000 out as a factor, and I get 1 plus 1.01. I can now go and put that in the calculator and get my answer to part A, which when you calculate that becomes $248,995. Okay, so for part B, I can now use my answer for part A. I am looking at this line where I've tried to establish a pattern, and from that I can conclude that a 60 is 250,000 times 1.01 to the power of 60 minus 3,000, 1 plus 1.01 plus 1.01 squared plus 1.01 to the power of 59. As always, then we need to state that this is a geometric progression. A is 1, common ratio is 1.01, and number of terms is 60. Then I can use sum of a geometric series to calculate my final answer. 3,000. So my A is 1, and then I have R to the power of n minus 1 over R minus 1, which gives me 0.01. Calculating that leaves me with $209,165.17. So that's sort of a reverse superannuation, or well, it's an annuity but withdrawal, and you can see, unlike the annuities we did before, the calculations and the process is more similar to a home loan repayment rather than an annuity calculation.